Hi students, today I am going to explain chapter 7 in physics, motion chapter. So in everyday life we see some objects at rest. So we see some objects will be at rest. At rest means they are not moving, and others in motion means they are moving. So birds will fly, fish swim, blood flows through veins and arteries, and cars move. So we can see some objects will be are not moving at rest and some are moving. So atoms, molecules, planets, stars and galaxies, all this will be moving. We often perceive an object to be in motion when its position changes with time. So in physics, what is motion or movement means when the object, we perceive the object is in motion when means its position changes with the time. So when the position changes with the time, it is called motion. So there are situations where the motion is inferred with indirect evidences. So from the indirect evidences we can know that motion is occurring. For example, we infer the motion of air. So how we know that the air is moving? When the dust particles move, or the leaves move, or the branches of trees move, we can say the air is moving. Like that also, how the phenomenon of sunrise, how the sun is rising, sun setting, change of seasons, all these are occurring. Why we know? Because the earth is rotating and revolving. Yes, no? Rotating around itself. So days and nights are occurring and revolving around the sun. So seasons are changing. Yes, no? Because of the motion of the earth only, it is all happening. So an object may appear to be moving for one person. So for one person, the object may appear as it is moving, or it is stationary for some other. It may be appear like it is stationary, it is not moving. How will you see? One example, for the passengers in a moving bus. So in a moving bus, the passengers are there. We see that the roadside trees appear to be moving backwards. So when we are sitting in a bus and it is traveling, we can see the trees are going backwards. And again a person standing on the roadside. See, the bus along with the passengers are moving. So we are just standing on the road, on the side of the road, and we see the bus along with the passengers moving, right? And a passenger inside the bus, he feels that he is in rest, and also the passengers is also in there at rest. And yes, no. So like this, the perception is different for different persons. So motion is a very complex process. Some objects may be moving in a straight line, other in a circular path, some may rotate and some may vibrate. All these situations may be in some involving all these. So in this chapter we are learning only the straight line, the objects which are moving in straight line. After that, in circular motion, we will find out the simple equations and graphs relating to it. Then, so describe whether the walls of your classroom are at rest or in motion. See the walls of your classroom, how they are in rest. Yes, no? Have you experienced the train in which we are sitting appears to move while it is at rest? So we will see. We are sitting in a train, it is not moving, but still we feel that it is moving. How? Because the other train besides us, it is moving. We feel that our train is moving. Yes, no? Then we sometimes are endangered by the motion of objects around us. Sometimes we are endangered by the motion of the objects around us. Endangered means danger. We are in danger. See, so suddenly floods are coming, a tsunami is coming. Yes, no? Like this. They are called uncontrolled movements or uncontrolled motion. And some movements like current, if you want, we can off or on. So these are controlled movements. So we will discuss this. Then how to describe a motion? We describe the location of an object by specifying a reference point. So one object is there, so we will specify the location of it by taking a reference point. So for example, so let us assume that the school in a village is 2 kilometers north of the railway station. So the school is 2 kilometers north from the railway station. Here the reference point is from the railway station. The landmark is railway station. The landmark is nothing but reference. So railway station is the reference point. Here we also choose the reference points according to our convenience. So to describe the position of an object, we want a reference point. It is also called origin. So the reference point is also called origin. Let's see. So let's see the motion along a straight line. So the simplest type of motion is motion along a straight line. So first we will see here by an example. Consider the motion of an object along a straight path. The object starts at O point and it will be moving along C, B and reaches A. So along the same path. So what is the distance covered by it is, so when it is going from A to C, C to B and B to A, it is covering 60 kilometers, right? Then again, if the same object is moving from O to C, C to B, B to A, and again it is coming back to C, reaches back to C, then what is its distance? Full length is, so we know that it is 60 plus how much it is? 25. So 60 plus 25, 85 kilometers. So what is its distance? It is 85 kilometers. Then, so it is distance. Then what about displacement? So distance is different, displacement is different. Distance means the total distance, how much it is, total path length covered by an object is distance. And here we do not take into consideration of the direction. So we don't take the direction because it is coming from O to A and again turned back to come to C. Here direction we don't take into consideration. We just count how much distance it traveled, how much length it traveled. So that is distance. And what is displacement? It is the shortest distance from point O to point C. Means from starting point to end point, what is the shortest distance? So I told from O to A an object is traveled and it came back to C. So what is the shortest distance? From O to C only you should take displacement. So how much? 25. So distance is 60 plus 25, 85, and the displacement is, so 25. Yes, no? Then is the distance and displacement same? No. So distance and displacement is different. Let's see here what they gave. So consider the motion of an object moving along a straight path. The object starts its journey from O, which is treated at its reference point. Then let A, B, C represent the position of the object at different instants. At first the object moves through C and B and reaches A. Then it moves along the same path and reaches C through B. So the total path length covered by an object is OA plus AC, that is equal to 95 kilometers. Yes, no? So then this is the distance covered by the object. To describe the distance, we need to specify only the numerical value. Here only we will take numerical value and not the direction of the motion. We don't take direction. There are certain quantities which are described by specifying only their numerical values. So the numerical value of a physical quantity is its magnitude. How much magnitude it is going. So only we take the numerical value. For example, can you find out the distance of final position of the C of the object from initial position O? So from O, what is the distance to C? So what is the shortest distance O to C? It is 25, right? So the difference will give the numerical value of the displacement. So shortest distance measured from the initial to the final position of the object is displacement. So distance is total length covered and displacement is from starting to end point. How much is there? 25. So can the magnitude of the displacement be equal to distance traveled? Yes, if the distance and distance traveled and displacement will be same. Yes. How? Consider the example from motion of the object from O to A. So O to A is 60. So that is the distance and displacement is also 60 because what is direction is not changed. So from O to A distance is 60, displacement is also 60. Then during the motion from O to A and back to B. So again from O to A and again to back B, the distance covered is 60 plus 25 kilometers, that is 85 kilometers. While the magnitude of displacement is, so from shortest distance from origin to final point 35. So here distance is 60 plus 25, 85 and the displacement is 35. So thus the magnitude of displacement is not equal to the path of the length, that is distance. So displacement is not equal to distance when there is direction. So even the displacement may be 0. How? So an object is moving from O to A and again it came back to O. Then what is displacement? It will be 0. Yes, no? So here we can see here. Further we will notice that the magnitude of displacement for a course of action may be, motion may be 0. But the corresponding distance covered is not 0. Distance covered will not be 0. But displacement may be 0 because it is going to the initial position. So these are the two different quantities we know now, displacement and distance. Then next is uniform and non-uniform motion. Let's see. First, an object is moving in a straight line. So in first second in 5 meters, second, next second 5 meters, third second 5 meters. So it is covering the same distance in the same time. Then it is called uniform motion. When it is covering unequal distance in the same time, it is called non-uniform motion. So let's see this table. So 9:30 am the distance travelled by object A in meters. 9:30 am 10. After that 20. In 15 minutes time gap, it is going 10 meters faster. So it is a uniform motion. Here it is not uniform because the numbers are correctly not increasing in a order. So it is a non-uniform motion. So that is about uniform and non-uniform motion. Next is measuring the rate of motion. Rate means speed. What is the rate of motion? Speed. So different objects will take different amounts of time to cover a given distance. So how much? If they cover more distance, more fast they are going. If they are covering very less distance, then they are going very slowly. Yes, no, objects move can be different. So and also different objects can move at the same rate also. So the rate of the motion of the object, how we have to find out the rate of motion? Rate is nothing but speed. Speed is equal to distance travelled by time. How much distance it travelled in a unit time. So when we are taking different speeds, so for example, one object is travelling 5 meters in first second, after that 6 meters in second, 7 meters, again 5 meters. So varying speeds, varying differences. Then we can take total distance. We just add all the distances travelled and all the time, total time. So we'll get average speed, total distance by total time. So V is equal to S by T, where S is the distance, T is the time. So let us consider this by an example. So a car is travelling a distance of 100 kilometers in 2 hours. So it is travelling 100 kilometers in 2 hours. What is its average speed? 100 by 2. That is 50 kilometers per hour. The car might have travelled at 50. What do you mean here? It is travelling only 50 kilometers per hour all the time. No, it may be travelling little fast or little slow. But the average is 50 kilometers per hour. So like this we can tell the average speed. Next is speed with direction. So here we didn't take into consideration direction. So speed. But if we take into consideration the direction also, then it is called velocity. So the speed of an object along with the direction is velocity. What is velocity? So when an object is moving along a straight line at a variable speed, we can express the magnitude of its rate of motion in terms of average velocity also. Same. See, speed is equal to distance by time and velocity is equal to displacement by time, because distance don't have the direction, so speed we can. But velocity have direction and displacement also having direction. So velocity is equal to displacement by time. So and average velocity we can carry initial velocity plus final velocity by 2. What is initial velocity? First velocity when the object is starting to travel. So initial velocity, after that final velocity at the last, what is its velocity? By 2. So average velocity is equal to u plus v by 2. So velocity, how we can calculate? Displacement by time. Speed, distance by time. Speed don't have direction, so distance also don't have direction. So speed is equal to distance by time. Whereas velocity have direction and displacement also having direction. Velocity is equal to displacement by time. If you remember this two, we can do easily the problems. So let's see the questions here. Speed, distinguish between speed and velocity. Speed is nothing but distance by time. Velocity, displacement by time. Speed is a scalar quantity because it don't have a distance, and whereas velocity is a vector quantity because it has magnitude and direction also. Speed we can calculate average speed is equal to total distance by total time, and average velocity we can calculate by initial velocity plus final velocity by 2. Like this we can calculate. Then under what condition is the magnitude of average velocity of an object equal to average speed? So when the average velocity, average speed will become equal. When means when they don't have direction. So like this we can tell. So let's continue the lesson. If you like it, just message me and the problems will be explained next week. Thank you.